Hello students, welcome you all to the next session regarding discussion on extrusion. In the previous session we have discussed regarding what is an extrusion process, how it is done, its procedure, types of extrusion, in which we have learned regarding what is a direct extrusion process, how is the direction of metal flow as well as the RAM in case of the direct extrusion process. Second one, indirect extrusion also. In today's session, we'll be discussing regarding the cold or impact extrusion, that is the third type of extrusion, and the fourth type, hydrostatic extrusion. After this, we move on to the parameters. There are some parameters which should be taken care to carry out an extrusion process. So in today's session, we'll be covering all these contents. So let us move one by one. So as I was discussing, we'll be discussing today regarding the cold or impact extrusion, that is the third type of an impact extrusion. So before we move there, let us refresh regarding the two types of extrusions which we have discussed in the yesterday's class. So in the previous session, we have discussed that whenever the direction of the metal flow as well as the direction of the plunger or the ram is in the same direction, then it is known as a direct extrusion process. Whereas if the metal flows in the direction opposite to that of the ram movement, then it is known as indirect extrusion. Today we'll be discussing regarding the cold or impact extrusion. So now the cold or impact, it is also known by another name known as impact extrusion. So we can say that generally here we are using a small slug, we say it as a slug, or a small quantity or shot of the solid cold metal which is placed inside a die cavity. So if you observe this picture here, this is the die cavity. So within this die cavity you can see this green color structure. What you are seeing, it is that slug or a small shot of cold metal which is placed inside the die cavity. This die cavity, it is shallow in nature, it is a little bit shallow, and to this die cavity where the cold metal is being placed, with the help of a force acting through the force is acting through the ram, which you can see here in the next second sketch. The force is activated on the ram, and as this ram moves towards the cold metal, you can see it gets extruded in this form. So you can see here the metal gets extruded in this form. So for a small slug or a shot of cold metal, we are using this process. So generally we are preferring for the cold extrusion or cold metal forming process, especially when the metals we are using such as tin, lead, aluminum and copper. For these kind of metals we are using this method. So during the operation, if you observe here, already there is some amount of initially we are placing a small slug or initially you are placing the small slug of material within inside the die shallow, or that is the shallow in the die cavity of this die, and as the punch moves downwards, that is in the second stage, you can see here, due to the impact acting on this cold metal, it gets extruded in the opposite direction of the plunger direction. So the plunger is acting in this direction, whereas if you see here the cold metal, it is extruded in the opposite direction on both the ends. So you can see here the green color metal structure which is coming in the opposite direction. Another important thing which you can notice here is between this punch and the die cavity, there is some clearance. There has to be some clearance. So if there is the clearance, then only the metal gets extruded. So this gap within which the metal gets extruded, we call, or we say that it is nothing but it is the thickness of the metal. And now as you are seeing that both the direction of the punch and the extruded metal is in the opposite direction, we say it as the backward type. So even in the cold or impact type, even you can have even the forward type also. Let us see how it happens regarding the forward type also. Yes, this is the forward impact extrusion process. So if you observe here, there we are having the punch which is acting upon the material present. This is the punch which is acting in this direction, and the metal gets extruded in the same direction. So both are moving in the same direction. So the punch and the material, that is the metal, it is extruded, they are extruded in the same direction. So we call it as a forward impact extrusion process. The things which we need to take care of here is, as we are using a small shot of the metal or a slug, the very important thing is the design of the dies, such that there should be good tolerance limits, there should be high accuracy, and this can be designed at a cheaper cost or a lower cost. But sometimes you have to take care regarding, as you are saying, the term known as impact, which means high amount of force is going to act on the die. So the dies have to be designed properly, which can bear maximum amount of impact, or you can say that it should have an impact resistance or a fatigue resistance, such that the life of the die is more. So it is these are the things regarding the cold or impact extrusion. Next, we go for the fourth one, that is the hydrostatic extrusion. So we shall go for the next one. Yeah, this is the hydrostatic extrusion. So if you observe carefully the picture, you can see in the picture, you can see that there is a ram to which the force is being developed, force is applied on the ram. Then you can see this is the work material which is present inside the container or a cylindrical container. Between this cylinder container and the work material, or you can say that is the billet, there is an yellow color structure. It is nothing but it is a fluid. So the name itself says here hydrostatic means the force which you are applying on this ram, it is not coming in direct contact with the billet. Instead of that, there is a fluid present between the ram and the billet, and the force which is applied on this ram, it is transferred to the fluid medium present here, and this fluid, it is applying the force on the billet. So this is regarding hydrostatic extrusion. So let us see these things one by one. So this is a type of an extrusion process where we are taking the help of an liquid which is being pressurized to apply the pressure on the hot billet, So you can see here all on the sides, the pressure is being applied with the help of this liquid. And you can say that this is the medium which is applying the pressure on this hot billet. So generally this workpiece which you are observing here, it is placed inside a sealed container which is surrounded by a fluid. This fluid, it is generally an oil, or we say it as a castor oil, which is nothing but R68, castor oil R68. During the operation, you should see that initially one end of the workpiece, that is this one end of the workpiece, it is to be tapered first. So that it can fit perfectly at this position. So it has to fit perfectly at this position. Yes, if you see here, which I am showing here. So initially the tapered end of the workpiece, it has to be fitted very perfectly at this position, so that there should be no gap. If there is gap, then what happens, as there is a fluid present behind the billet, there is a leakage. So you should see that the designing has to be done very perfectly. Then this container, which is already having some pressurized fluid, when the ram is brought into the container, then what happens? This pressurized fluid develops the pressure on the billet, and the billet gets extruded through this dies. So the billet gets extruded through this die here. So here if you observe this particular feature, even the design of the dies, if you observe how it is different when compared to the other three extrusion process. So what you can say that here we are having very low cone, low semi-cone angle. We call it as low semi-cone angle. Why? Because as we are having an initial tapered part, so automatically even we need a low semicon die angle through which the metal can get extruded. This is the one first important thing. Second very important thing here is when compared to the other extrusion process, that is the direct, indirect, as well as in case of the impact extrusion, there was, for all those three cases, there was a friction force. Friction was developed between the container. Friction was developed between the container and the billet. But here in this case, if you observe, the billet which is there, it is at some distance away from the container, which means there is no friction between the billet as well as the container, which means there is absence of friction, or you can say negligible friction is there. First important thing. Second important thing is, as this billet is surrounded by the oil, it is acting as a lubricant, which means when the material gets extruded through this low semi die angles, then even the surface finish and the quality of the product is very much good. So you can say that we can get good quality. So there is an increase in ductility, but sometimes it also leads to the brittle materials. The disadvantage which you can see here is, as I was telling you, we are using the fluid inside this container between the billet. So you should see that the design has to be done very accurately. First important thing. Second important thing is to make this entire structure, it is takes more amount of money, which means it is a high cost process. And the third important thing is regarding the speed through which the ram is forced to move towards the fluid, that speed. So maximum pressure is around 1.7 gigapascal. This is to be there. So if it is above this, then it becomes very uncontrollable and automatically damages the entire setup. This is regarding hydrostatic extrusion. Now, let us move on to some of the parameters which are responsible for controlling or for very much important to carry out the extrusion processes. So you can say that these are the extrusion variables, or you can say that even the parameters. So you can, if you observe here, the 5 parameters of the variables are, the first one is the flow stress. You can say that the alloy, the very important thing is the alloy flow stress. Second important thing is the ram speed. So what should be the ram speed? Then third important thing is working temperature. So we already know that for various metals, they are having their different melting temperatures. So you should know what is the working temperature for each metals. Depending upon that, what is the amount of ram speed required and what is the type of pressure required. So then we should also know regarding the extrusion ratio, and another term, it is the extrusion shape factor. So these are the things which we need to know. So let us move on by discussing regarding these things in brief. The first one is the alloy flow stress. The alloy flow stress. So the alloy flow stress is a thing, but already we have discussed in the previous sessions. If there is instantaneous value of stress which is required for deforming the material, then what happens? The material is flowing uniformly. So there should be instantaneous value of stress which is very much required for the deformation of the material. And apart from that, this alloy stress is nothing but it is a function of a strain. So it is a function of a strain. The alloy stress is nothing but it is a function of a strain. So in other words, yield strength of this alloy flow stress is a function of the strain. So as the extrusion force which is required here for the alloy flow stress, it is again characterized by some factors. So as I was telling you, we are having various different kinds of metals. You should know regarding the chemistry and metallurgical structure of the different metals. You should know regarding at the temperatures, the working temperatures, where at which particular point the deformation of the various metal happens, and at those temperatures, what is the amount as well as the rate of deformation process. This we need to know. And another important part is always the flow stress which is there, it starts to decrease. It starts to decrease as the temperature goes on increasing along with the increase at a higher strain rate. The next is regarding the ram speed. So as I was telling you, even the ram speed plays a very important role in applying the force onto the billet, which is responsible for developing extruded products. So if you are increasing the ram speed, then automatically what happens? It is increasing the extrusion process pressure. So that is directly proportional. But apart from that, when there is a higher temperature for the billet, then there will be the greatest effect. There is more effect which is developed due to low extrusion speed. This has to be taken care, because when we are using some of the soft materials such as aluminum, copper, we have to decrease the speed. We have to decrease the speed. But if you are using the materials such as the steel, titanium, and other materials which are having high strength, there what happens? The speed of the ram has to be increased because their material strength is more. So here also, as I was telling you, when you are having higher extrusion speeds, means if you are having increasing the ram speed, then what happens? Even the temperature rises, and this is due to deformation, which is having a greater impact. So as I was telling you, for every kind of a metal, we should select a proper extrusion speed or a ram speed, where temperature is to be best determined by trial and error for each of the alloys as well as the other materials. So if you're having some high extrusion speeds, then we should have good high strength materials. And if you're having low strength materials or the alloys, we should operate at the lower speeds. This is regarding the ram speed parameter. Let us move for the next one, temperature. So as I was telling you from the first session itself, that extrusion can be carried out for both hot working process as well as for cold working process also, depending upon the types of metals which you are deforming at various temperatures. So if you observe right now here, the first point itself, they are saying that the hot extrusion process, when you are carrying out, what happens? It is varying one parameter, that is the thing, but it is the decreasing the flow stress of that metal at higher temperatures. But if the flow stress is decreasing, the problem is that at the surfaces there is oxidation, and which will reduce the quality of the material automatically, even the extrusion tools also. So therefore you should have a minimum temperature such that at that particular point plastic deformation occurs. So you should know the minimum temperature for each kind of the material which is responsible for developing or starting the plastic deformation state. If the plastic deformation is higher, then what happens? Sometimes there are cases that even it leads to the internal heating of the metal also. Therefore, you should know that a maximum working temperature which we are using, it should be always below the melting point, which we have already discussed in the basic part of the metal forming process. Generally, what we are using, the steel billets, the temperature ranges is in the value of around 11 degrees, 100 degrees Celsius, 1100 degrees Celsius, or 1100 degrees Celsius to 1200 degrees Celsius. And for toolings, you have to go for preheating around 350 degrees Celsius. This is regarding the third parameter or variable, that is temperature. Next, we are having extrusion ratio. So in very simple words, extrusion ratio, what you can call that, it is nothing but a ratio of the cross-sectional area of the billet to how much part is extruded. So initially you should know what is the cross-section area of the billet, and after the extrusion, whatever the cross-section area is there, which we are taking there to them together to get the ratios, we call it as extrusion ratio. So the cross-section of the billet, will be greater than that of the extruded part, as we know. So therefore, the extrusion ratio, it will be always greater than 1. If for the materials the profile is very low, then what happens? In those types, the property, that is the plastic strain, it is always going to reduce, or it is low, because the extrusion ratio of a profile is low. This is regarding extrusion ratio. Another fifth variable, that is extrusion shape factor. So again, it is a part itself. So here, this extrusion shape factor, if you observe, this is also nothing but it is mainly dependent upon, or it is a ratio of the parameter of the extruded cross section to the same perimeter of the circle. So here you take the circle, because generally in the extrusion process, the profiles which we are developing, they are the rods or the cylinders itself, which are cylindrical in nature, so circular in shape. So therefore we take it as the same parameter of circle. So generally here, when you take this one as a circle, its shape factor is always 1 for circle profile, or for circular profile, the shape factor is always 1. And this shape factor, it increases if the part or the product which you want to develop, its nature is more complex. So the shape becomes more complex, then what happens? The value of the shape factor, it also goes on increasing, which becomes due to more complex natures. So if you're having more complex shape, then what happens? Automatically your shape factor increases. If you are having a more shape factor, then whatever the force you want to apply on the ram, it also increases, because you are developing the complex product. So always, for the extrusion process, we prefer the cylindrical or simple shape products. If the shape is going to be having complex, then what happens? Even the force required for extrusion, it also goes on increasing. So these are the things we need to know, and the parameters regarding the extrusion process. So if you have any doubts, I will leave my mail ID in the YouTube, so through which you can mail me and get clarified your doubts. So today, these are the things we have learned regarding what is cold or impact extrusion, hydrostatic extrusion, then the variables, as we have discussed, regarding the flow stress, temperature, extrusion ratio, extrusion shape factor, as well as ram speed. So we shall conclude here. Thank you, students.